Hey there, good morning everybody. I hope this all finds you well and healthy, and we're ready to go with this algebra lesson today and talk about operations with functions. Now our math operations, if you remember, four basic ones are add, subtract, multiply, divide. So we're going to talk about how to add, subtract, multiply, and divide functions this morning a little bit. And then as you see here that it's part one because there's actually another function operation that I need to talk to you about, but it's more unfamiliar, so we'll hit that tomorrow. So the way that we show functions, remember, is f of x or g of x or h of x or any of those different ways. This is usually like a substitution for a y value. But when you put them together and you put them together by addition, we combine this, saying that we have a combined function of f plus g, which really only means that you're going to add the function f plus the function g. And we'll get some examples of this so that it becomes clearer, but the same things happen with subtraction. F minus g of x is f of x minus g of x. F times g of x is f of x times g of x. I do have to make a special note of this. Notice that this is a raised dot, and that's super important because that new function, which is called a composite function that we'll talk about tomorrow, actually has like a circle here. So depending on your handwriting, I can't recall if there's anybody in this class that has this, but some people I notice sometimes put a little hole in the middle of their raised dot. Be very careful of this here because we need to make sure times means times, and something that's just a little circle that's not filled in means something else. So we'll just hold that off, but be careful with your notation. And then divided by. Divided by is a little bit special because I have this little side note that's actually part of this, is that g of x can't equal 0, and that'll come into play before the end of the lesson. But just keep in mind that divided by is special because it means that there are some exclusions for our value for our combined function for division. All right, well, the best thing to do is to jump in with an example here. We have f of x is a defined function, if g of x is a defined function. Now these functions, of course, can change depending on what problem you're doing. You always have to have them defined somewhere to start a problem. And we're supposed to find the sum, f of plus g of x. And this is as easy as it sounds. You're taking your f of x function and you're adding it to your g of x function. This is a plus. So when we put them together, you really are looking for like terms like you've always done. 4 and 1 make 5, so 5x plus square root 7 plus 7. You can't put a square root with something that doesn't have a square root, and you can't put an individual number with something with an individual number. So we look at this question. This is our important new question, is what is the domain? Remember, the domain values are anything that x is allowed to be. So when we look at this combined addition function, what we find is we've got a square root of x in it. Now we're looking for the domain being the values that x is allowed to be in the real number system. We're not dealing with the imaginary numbers at all here. So we look at these. This one makes it appear that, oh, x could be anything. But when we look at this, you have to realize that x has to be a positive number. So since x has to be a positive number, that means you can't have any negatives in the domain. 0 is the smallest number that you can have for x, and you can have all the numbers that go up from there. So what I have here is a formalized way of saying that. This means the set of all values of x such that x is greater than or equal to 0. The set of all x such that x is greater than or equal to 0. A very formalized way of just saying that the value of x has to be positive or 0. And as far as y, I just talked through all that, but sometimes it helps to write it down. So we've got this. X can be anything for f, the f function, and greater than or equal to 0 for the g function, because you can't take a square root of a negative, so f of g has to have x being greater than or equal to 0. So if this wording helps you to be able to find the domain, then you need to go ahead and write this down for yourself so that you can remember where this came from. Okay, let's move on to subtraction. For subtraction, it's almost as easy as addition, except for you're subtracting. You do have to be careful, though, when you're subtracting, to make sure that you subtract the whole second function. So here's our first function, and you're going to subtract the second function, which means watch out for this negative. It has to get distributed. So minus square root of x minus x. And then put your things that are alike together. 4x minus x gives you 3x plus 7 minus square root of x. So make sure that you are distributing, make sure that you have that taken care of. Now the same thing when we're thinking about domain, we have the same issue, is you have a square root of x back here in this g function, which means that it has to be everything that's greater than or equal to 0. Same reason that I said in the last one. And we would say this all x such that x is greater than or equal to 0. This is in set builder notation. You will see that all over in your future maths, so please make sure that you learn how to actually write it like this. In order to make this bracket or brace, sometimes it's a little bit hard for people to get the hang of that, but just so that you can remember that you're moving like this in order to make the braces. Some people have trouble getting the actual swish down with that, but you can always do bump, point, bump, bump, point, bump, if that helps you out, because that's good enough and everybody knows what you mean with that. This is the more elegant one, but practice that a little bit. All right, moving on. The multiplication one. So multiplication is, notice that I've changed our f function and our g function. They can be anything, but I wanted to use this particular f and g for an example on purpose. When you multiply, do the same thing that you would for multiplication. Make sure that you're multiplying the whole first function times the whole second function, so it involves distributing twice. This x squared gets distributed, so x squared times x is x cubed. X squared times 3 is 3x squared, minus 9x minus 27. Nothing here can get put together, but you always do look for your like terms to put together. Now the domain for this is interesting. X can be any number here. X can be any number here, so the domain tells us that there's no restrictions on x. Okay, so the domain is all real numbers. The formalized way of writing that would be this r that has an extra line on the side to represent all real numbers. You don't have to necessarily even put it in set builder notation because you've got this symbol right here that means all real numbers. The way that you write that is, just in case somebody doesn't know, is you just go like this and make 2 and make your real number symbol like that. Okay, so all real numbers for that one. F divided by g of x. So with this, when we put this in here, once again, you've got a group in the numerator, a group in the denominator. This is where you have to remember how to factor. So when you factor this, this is a difference of two squares. Hopefully you remember. If you don't, let's just go over it a little bit. This is x squared, this is 3 squared. So if you have an x plus 3 times an x minus 3, that would be the same as x squared minus 9. You might need to review your chapter on factoring or find some information on that if you're a little bit rusty on that. Now here we have x plus 3, they can cancel out. So the really neat thing about this is this function really reduces down to x minus 3. If you were to graph that, it looks like a line because it's mx plus b form. You'd have a line. The thing is, though, in this one there would be a number that would not be allowed to be used. And this is where our domain comes in. You have to make sure there is no 0 in the denominator. In other words, x plus 3 can't be equal to 0. Even though we simplified it down and it got canceled out here, in the original function, x plus 3 can't be 0. So that means in our final answer, even though we have this in simplified form, you have to keep that idea that you have a restriction on x. So if x plus 3 can't be 0, that means x can't be negative 3. Because negative 3 is the value that if I put that in here, I'm going to end up with a 0 in the denominator. X cannot equal negative 3. This is all x such that x does not equal negative 3. It can be anything else in the whole universe except that. And a lot of times a domain will show the restrictions in this form. Okay, we have another something to take a look at. We're going to look at multiplying these two. Don't forget, when you multiply a trinomial times a binomial, you do have to multiply everything in the first polynomial times everything in the second. This is a bit of a review, but it is in good context here, so I need to take this 3x squared and distribute it. 3x squared times 3x. Actually, I'm going this way. 3x times 3x squared is 9x cubed. 3x times negative 11x is negative 33x squared. And 3x times 4 is negative 12x. 1 times 3x squared, 3x squared. 1 times negative 11x, negative 11x. And 1 times 4 is 4. In either if you're multiplying this way or if you're multiplying this way, either way you have to make sure everything in this polynomial gets multiplied times everything in this polynomial. Then here there are actually some things that can get put together because we have negative 33x squared and 3x squared that can get put together because they're like terms. And you have negative 12 and negative 11 that can get put together because they're like terms. And then you've got that leftover negative 4 here. So this is our simplified form. There's no restrictions on either one of them. X can be anything. So our answer is all real numbers, or you can write that big fat R if you want to. Okay, and although since we're doing this online, I would caution against making, there's no way to put that big fat R in as far as typing it in for an answer. So actually write out the words all real numbers, because the capital R is reserved for something else, and we just want to make sure that we're being consistent on that. Not that, but it's that double line thing that makes it special. All right, one more, and then we'll be done for today. I want to do the division of the same function. Okay, so we take a look and we need to divide this out. Now, if you remember, if we're going to factor this, all right, this is not a 1 coefficient. Again, you might want to go back and review some of your things about factoring, but since this is not a 1 coefficient, I have to multiply the first term times the last term. That would give you negative 12. And the factors of negative 12 that when you add them give you negative 11 would be negative 12 and 1. So we would break this down. Negative 12x and 1x. Because the factors of negative 12 that when you add them together give you negative 11 are negative 12 and 1. Then you can group them. This should be an x squared, by the way. I just noticed that that was missing. I don't know if it's going to let me do that. All right, there's going to be a 2 there. Hold up a second. There we go. There's my 2. 3x squared minus 12x plus 1. X minus 4, and we need to factor by grouping here. So I've got my 3x squared minus 12x. We need to factor out a 3x here because that's in common. And there's nothing in common here except for a 1, but we factor that out as well. 3x, there should be an x here. So we factor out a 3x here because there's a 3x in common between these. So 3x times x is 3x squared. 3x times 4 is negative 12x. And you've got this 1 here that was factored out because there's no other common factor here. So 1 times x minus 4. And then once you have brought this all out, 3x plus 1 times x minus 4. So the 3x plus 1 can cancel and you're left with x minus 4. And so we need to then consider our domain. X minus 4 is a very nice simplified thing, but we have a restriction because back in our original expression, 3x plus 1 can't equal 0. So I want to just show you a little bit how you can find that. 3x plus 1 can't be 0, so you solve it just like it's an equal sign. And you get negative 1/3. So our domain is that x can be anything, all x such that x can't be negative 1/3 though. So here's our domain in that. So going through all of these different things with all the different little twists and turns in that, hope that all made sense to you. So addition, subtraction, multiplication, and division is really nothing more than a notation thing. As far as now you've got the F and the G put together like this, and then when you finish it off, you do have to just watch out for your restrictions. Tomorrow we'll tackle composite functions, and I hope that you have a really good day. God bless you and your family, and stay healthy.